Human computation is the secret sauce that makes crowdsourcing work. It's an offshoot of artificial intelligence, which is about making machines smarter. Human computation puts a special twist on this by cheating. Instead of trying to make smarter and smarter machines, we let machines do the things they do best, like counting and keeping track of things, and then give the really hard jobs to people. Turns out that in many cases, this is an effective combination. When people talk about how powerful a computer is, they're usually referring to how fast it can process information. And indeed, some supercomputers today are approaching the processing speed of the human brain, though they require about 1 million times more energy than our 20-watt brains. But speed alone is not sufficient to create intelligence. It's really about the software. And the software that runs in the human brain is the culmination of millions of years of evolution, optimizing the most complex information processor in the known universe. We still don't know how to replicate this complexity in machines, so we turn to humans for things like abstract thinking, creativity, and knowledge about how the world works. Today, we're caught in a bit of a rut. Just as with the supercomputers, the software is the main issue. Most human computation applications involve simple microtasking. The computer breaks down a big problem into tiny pieces and then sends out these little microtasks, which are all basically the same, to lots of people and then puts the pieces back together. The Stardust at Home project, for example, had 1 million images of aerogel to search through to try to find just 5 interstellar dust particles. So they engaged 30,000 members of the general public to help out. But microtasking only applies to a narrow set of applications that involve large, uniform data sets. In order to address the wicked problems that face humanity, like climate change, pandemic disease, and geopolitical conflict, we need new approaches. These are dynamic, multifaceted problems that may have solutions that create even worse problems. So to attack these issues, we need to build information ecosystems that can help millions of people reason together effectively and build models of the problem space that allow prospective solutions to be evaluated in theory before they're implemented in practice. This is the real technical challenge and goes back to the software question. We need to design workflows and patterns of interaction between humans and computers that will actually result in problem-solving behaviors that exceed our best abilities today. As a starting point, we need effective examples, such as the human brain itself. In a sense, we're trying to build a distributed brain in which each neuron is a person or a computer. We also need to conduct systematic studies that compare different approaches and build a body of work that helps inform the development of future systems. This is a tricky one. There's the problem of individual people or organized groups with malicious agendas trying to influence the behaviors of these systems. And then there's the issue of these systems themselves developing collective thoughts and behaviors that transcend the awareness of individual participants. In other words, the machine gets a mind of its own. Some early work has been done to identify the potential issues that could arise in both of these cases, and the community has been developing guidance concerning transparency, informed consent, and meaningful use. But certainly more work needs to be done here. Ironically, human computation may actually help advance artificial intelligence in 2 ways. As new machine capabilities arise, perhaps we can gradually replace the humans in these systems until eventually they're mostly automated. In addition, human computation systems themselves might be used to solve the problems of advancing machine-based intelligence. So I think these 2 paths, human computation and machine intelligence, may end up being mutual catalysts. Either way, I don't see machine intelligence surpassing human intelligence in the foreseeable future, but putting the 2 together could produce something that's more than the sum of its parts.